Welcome back to Eezytutorials. We are seeing Breadth First Search traversal. We are going to see one more example in this video. This example will be quite different because so far we have seen directed graph and this example is an so far we have seen undirected graph and this example is a directed graph. We are going to start from A. Generally in an undirected graph, the edges which are the nodes which are connected directly to a particular node will be considered neighbors. Here only you have to see the arrow marks. If you are considering A, the neighbors are only B and D. C is not a neighbor because the arrow mark is from C to A and not from A to B. So from A to D, the arrow mark is only for D and B. So the neighbors for A will be only D and B. You have to perform or consider the neighbors like in this way. So we can start with A. So the neighbors for A from the graph are only B and D. So what is the step? You have to dequeue an element from the queue after enqueuing all its unvisited neighbors. So initially I am starting from A. So I am putting A into the queue. Now I am enqueuing the unvisited neighbors B and D because initially I have not at all visited any nodes. So B and D I am enqueuing it. So I am making the visited status for A, B and D to be 1. So now I can output A or I can dequeue A from the queue. Now the next front element in the queue is B. So from the graph the neighbors for B I am seeing it is C, G and E. So the neighbors for B are C, E and G. I have to here C, E, G all the three elements are not yet visited. So I am enqueuing C, E and G at the end of the queue. Then I am making C as visited, E as visited and G as visited. Now I can dequeue B to the output screen. So the next front element is D. From the graph the neighbors for D is only C. So the neighbor for D is C. I am checking the visited status. C is already visited. So I need not enqueue any element into the queue. I can dequeue D to the output screen. So now the next front element is C. The neighbor for C is A. A is already visited. So A is having visited status as 1. So I need not enqueue any element. I can dequeue the element C to the output screen. So my output is A, B, D and C. Now I am having E as my front element. The neighbors for E I am checking in the graph. E is having only one neighbor H. I have not at all visited H. So I am going to enqueue H into the queue. So E, G is already present. H I have enqueued into the queue. And now I am making the visited status for H as 1. After performing this step, I can dequeue E to the output screen. Now I am having G. So the neighbors for G are F. So F also I have not at all visited. So the neighbor for G is F. I am enqueuing F into the queue at the end. At the rear part I am enqueuing and I am making the status of F as 1. Now I can dequeue G. So already I am having A, B, D, C, E. I have dequeued G. The next front element is H. So now the neighbors for H are G and F. I am checking the visited status. G is also visited, F is also visited. So I don't want to enqueue anything. I can dequeue H to the output screen. Now the front element left is F. So F is not at all having any neighbors. From the graph you don't have any outward arrow from F. So you don't have any neighbors. So F, you need not enqueue anything. You can dequeue F to the output screen. So now I am having an empty queue. So if I am having an empty queue, I can stop the process and this is my final output. So my final output is A, B, D, C, E, G, H and F. So this is my final output. This is how I have to perform breadth first search. So we are dequeuing an element from the queue only after enqueuing its unvisited neighbors from a graph. This is what you have to perform. Stay tuned to Eezytutorials to watch many more examples and other lectures related to data structures. Thank you.